Hey guys, so today what we're going to do is we're going to talk about pressure. I prepared notes for you, and instead of just having you read through them and take notes, I wanted to kind of teach them so that we can kind of simulate me and us being in the classroom. So, yesterday you watched a video about pressure, and the teacher teaching this video gave you a demonstration with a finger applying to his forearm and the bare hand or the smooth part of his hand or palm applying to his forearm. And you guys also kind of did that little lab and you could experience the difference in pressure. But we're going to talk about more of that later. And then he kind of just went briefly into what pressure was. Today we're going to expand on that a little bit more through these notes. So first off, we need to talk about what a fluid is first because the video did not talk about that. So fluids are any substance that can flow and take the shape of its container. So these are typically liquids and gases. Now you can't see air or gas normally, but you can see liquids. We're going to use water as our example. When water is in a water bottle, it takes the shape of that container. So it looks more narrow, it runs up and down, and then when you drink it or it's depleted, there's only so much water in the water bottle. But the water can't go past the bottle, which is why it takes the shape of its container. If you looked at a large body of water like an ocean, there's a hole in the ground or there's a gap there, and the water fills that gap. The water is still filling the shape of its container, quote unquote, but it looks differently. It's more flat, and then you just see depths of water when you jump into the water, where you go swimming or scuba diving. Gases would look the same way in the sense of its shape. It's taking the shape of its container, but we can't really see the gases or air. And you also learned what pressure was in the video yesterday. Pressure's definition is the amount of force per unit of area applied to an object's surface. So it's the amount of force applied per unit of area of the object or the surface that the pressure is applying to. We'll get into more of that in a little bit. Pressure of fluids. Now, remember when we did speed, acceleration, velocity, and Newton's laws, we were calculating what force was, what speed was, what acceleration was. We can do the same thing with pressure by using the pressure equation. Pressure equals force divided by area. That's its equation. So normally you would be given a force and an area, and you'd be asked to find pressure. So you would take your force and divide it by your area. We're going to practice with this more throughout the week. Don't worry about getting it right away. And remember, when we had speed, we had the units meters per second. That was our normal unit for speed. Or when we had velocity, it was a direction in meters per second, and then acceleration was meters per second squared. Our unit for pressure is Pascal, which can be abbreviated PA. With direction of pressure, I know the video didn't talk a lot about this, but pressure is not normally or typically applied in one direction, but is usually applied in multiple directions. A fluid applies pressure perpendicular to all sides of the object. Now I'm bringing in a whiteboard to show you what I'm talking about. If you look at our arrows, remember, parallel, I abbreviated para. Parallel, these lines will never touch. They're going to keep running and running and running and going, but they'll never touch. Perpendicular, one line's going horizontally, one line's going vertically, and they touch and form a right angle. That is what happens with pressure when an object that's applied by pressure. When an object is placed in a fluid and its pressure is applied. Now look at the example that I was just talking about. Here's our metal cube. Think about the cubes from the beginning of the year when I brought them in when we were talking about like the science practices. We have a metal cube, we have a container of water. Notice the water is applying force to all sides of the cube, perpendicular to all sides of the cube. That is what happens typically. So direction is multiple, not single, not singular. Lastly, what you saw yesterday when you did when you applied pressure to your forearm with a finger versus with your hand. Pressure and area have a negative relationship. That means when one increases, the other decreases. So if we look, when the overall surface area increases, the pressure decreases. When the surface area decreases, the pressure increases. So this is directly applicable to your example yesterday. When you had your one finger, that was a smaller surface area. So you felt more pressure in your forearm when you applied the pressure. But when you used your heel of the palm and you applied pressure to your forearm, it didn't feel as much. The pressure was less because the surface area of your hand is greater than the surface area of your finger. Your finger's applying a lot of pressure to one little area of your forearm, whereas your heel of the palm is applying pressure, but it's less because it's more surface area. Your palm is bigger than your finger. The palm has a greater surface area, so the pressure is lower. So as surface area increases, the pressure decreases. When surface area decreases, the pressure increases. That's going to wrap up this lesson. What I need you guys to do now is look at the PowerPoint notes, take what I taught you, and fill in the notes and answer the exit ticket. Make sure you submit both of them by 11:59 tonight. Thanks, guys. Have a good day.